AI systems are not intrinsically neutral. They often reinforce biases in data and algorithms. Due to the diffusion of AI systems that permeate society, such errors have a huge impact. Consider, for example, an AI system used for hiring. The system learns from past data in which most managers were men. It thus favors male candidates because from a data a pattern emerges of men being hired more often for such roles. This reinforces gender bias in hiring. But what is bias? In statistics, bias is the tendency of a statistical technique to either overestimate or underestimate the true value of some parameter. When the model is too complex so that it fits the training data too closely, leading to poor generalization, we talk about overfitting. When the model is too simple, leading to poor performances, we talk about underfitting. Bias is thus a systematic departure from a certain standard of correctness. Different things can be biased. People, individuals in their social role, for example, the biased judge, objects, the biased coin, things that can play the role of evidence, biased data. Recently, the term biased algorithms have been coined, referring to a systematic error in automated processes that causes unfair outcomes for certain individuals or group of people. For example, an algorithm for hiring that automatically and systematically excludes candidates younger than 25. There are different types of algorithmic bias. For example, bias can occur in datasets or in labeling. Bias in data happens when data are incomplete or inaccurate. For instance, data might be collected in a too limited time range, or some data might be systematically excluded. Also, cultural prejudices might be included into systematic processes. This can also occur in generative systems that predominantly offer images of young white male individuals when prompted with a successful person. Bias in labeling happens when labels are incomplete or inaccurate. For example, data points might be assigned to incorrect categories. We now focus on the particular case of label bias. A common example of this kind consists in errors resulting from mixing animal species, such as a cat mislabeled as tiger or a husky with a snowy background, which is typically confused with a wolf. It is demonstrated that the most well-known AI datasets are full of such labeling errors. As a result, databases containing errors transfer them to the system they train and to the real applications, generating new ones. But why do such errors occur? A common reason is intrinsic to the labeling itself. Indeed, the AI automatic categorization is built on a particular process which involves human force. In particular, people called crowd workers classify millions of images for a few cents. Therefore, one of the reasons for label bias is that human labeling categories might be biased themselves, transferring their bias to the system. In particular, when dealing with people, the impact of algorithmic errors due to mislabeling is undeniable. Indeed, when they try to classify people, algorithms seem to ignore important aspects, something which is reflected in technical errors. Consider the case of Google Photos, developed in 2015. This tool offers the automatic recognition of photo contents by identifying features and subjects to collect similar ones together. A few weeks after its release, a dark-skinned person found a problem with the automatic labels of pictures. Google Photos had classified some photos of him and his friend with the gorilla tag. The described approaches recall phrenology and physiognomy, that is, the fact that a person's character and behavior can be derived from facial physical features. Those disciplines have been proven to be pseudoscientific. However, they seem to be at the basis of a functioning of face recognition, which seem to be built on similar assumptions. However, face recognition technology is an increasingly widespread application in the AI landscape. It is used in many domains, such as advertising, security, soft biometrics, human-computer interaction, healthcare. It is embedded in any type of technological tool, from filter apps on social media to the intelligent robots for house cleaning. Such tools aim to algorithmically identify particular features of individuals from visual images to classify individuals into predefined categories. Depending on the application, face recognition systems are also used to make inferences about individuals affecting human lives. Consider the case of Compass, a risk assessment tool used by US courts for recidivism prediction. A famous analysis of the tool shows that the system scores appear to be racially biased, as it incorrectly labels dark-skinned defendants as high-risk subjects. This means that dark-skinned people are characterized by a higher risk of recidivism after being arrested. This tool has been used in US courts to assist judges during sentences, thus dramatically affecting people's lives. When technology is applied to people, bias leads to discrimination. The task of mitigating discrimination pertains to the context of fairness. Fairness is a multifaceted social construct, At a high level, it can be understood as non-discrimination. In general, there is not a unique definition of fairness. In addition, in the algorithmic context, a great number of different approaches exist to define and reach fairness in algorithms. A typical distinction is the one regarding the two classical distributive principles of equality and equity, which are often used to define fairness and reduce discrimination. On the one hand, equality means that each individual or group of people is given the same amount of resources or opportunity to reach a goal. On the other hand, equity states that due to personal differences, each individual is allocated the exact amount of resources or opportunities needed to reach a goal. Due to the large amount of definitions and approaches, different taxonomies exist to categorize fairness. If you consider the level, fairness can be defined as individual or group fairness. Individual fairness means that similar individuals should be treated similarly. Consider, for example, a hiring algorithm that evaluates candidates for a job. If the applicants have similar qualifications, individual fairness requires the algorithm to evaluate them similarly. Group fairness means that groups defined by protected attributes or sensitive features will receive similar treatment. Consider, for example, an algorithm used in healthcare context to prioritize patients for organ transplants. Group fairness requires that patients from different demographic groups, such as ethnicity, have similar chances of being prioritized, assuming they have similar needs. Another way to categorize fairness definitions is to consider the step of the algorithmic pipeline in which the applied definition has to intervene. Following this approach, fairness can be classified into pre-processing, in-processing, and post-processing fairness. Pre-processing fairness considers the data that algorithm will use and tries to correct and mitigate bias in the dataset. This means, for example, removing information that can lead to discrimination, such as gender, from data before training a hiring model. In-processing fairness looks at the model, intervening in the algorithmic process. This means, for example, adding a specific rule during training that ensures men and women are treated equally in the hiring process. Post-processing fairness works on the outcomes, operating at the end of the automatic processes. This means, for example, that if it is the case that the model hires fewer women than men, their selection rate after the predictions has to be manually increased. We have seen that technology is not neutral. Instead, it is always a reflection of culture. Today's technology represents a slice of society, and this is particularly evident in the case of AI, which is rapidly expanding its realm of application. In this video, we have seen this through the example of face recognition technology, and precisely reflecting on the task of classification. Mitigating the discrimination resulting from technology is possible, and a way to do that is to build fair models, which ultimately leads to a just society.